programs. To facilitate this, we need to bring about a better understanding between US and Indian institutions of higher education on how to design and deliver study abroad programs.
We're a membership association that provides training and resources to education abroad professionals around the world. I'm looking forward to working with workshop participants to build capacity in India to host students from US universities on education abroad programs.
Register today to be a part of this collaboration and conversation.
The greenery, the people around, the facilities that we have, it is one of the best places to live in Chennai. The community is another added advantage of being inside the campus. Campus has two schools, one is CBSE based and the other one is the state board.
It's a pleasant experience for the kids as well, because they don't have to worry about going in search of any facilities. Everything is available on campus. We have a shopping center in the residential zone as well as in the student zone. We can go get anything right from the vegetables, groceries, or clothes, or bakery and eat outs.
You don't have to step out of the campus for anything. So it is a self-sufficient campus, which has been a great blessing for all of us.
The Institute of Eminence scheme has been launched by the Government of India to empower higher educational institutions and help them become world-class teaching and research institutions. IIT Madras is proud to have been selected as one of the select institutes of excellence. As part of our commitment to the cause of fostering world-class research, IIT Madras has set up a number of research initiatives in diverse fields of contemporary relevance. Many of these initiatives will go on to become centers of excellence within the IIT Madras system. A total of 68 research initiatives belonging to 21 identified technology clusters are presently underway.
Hello and good day to everyone. Thank you for joining us today. On behalf of the Office of Global Engagement, it is my pleasure to welcome you to the 67th webinar from the IRIS webinar series. My name is Richu George and I'm a part of the Office of Global Engagement at IIT Madras. The Institute of Eminence scheme was launched by the Government of India to empower higher educational institutions and help them become world-class teaching and research institutes. IIT Madras is proud to have been selected as one such Institute of Eminence. A total of 68 research initiatives belonging to 21 identified technology clusters are presently underway at IIT Madras. And as a part of these initiatives, the IRIS webinar series aims to showcase the innovative research being generated to various stakeholders like the students, researchers, industrialists, and policymakers. From the Advanced Manufacturing Technology Cluster, the research initiative presenting today is titled Ceramic Technologies, led by Professor Ravi Kumar. This center is to specialize in advanced ceramics that will pioneer the future of energy and mobility. The center aims to ensure a truly international research environment and build up an innovative global hub dedicated to transformative ceramic science and technology for the future. The research leaders at the center will facilitate to close the gap between lab-scale research and industrial applications. To introduce Professor Ravi, who is a lead PI of the project, he's a professor of ceramics and head of the Department of Metallurgical and Materials Engineering at IIT Madras. He has been a visiting professor at various institutions abroad and is currently executing several bilateral projects with various international institutions. He is a recipient of various awards, which includes the Institute Research and Development Award in 2015 and Young Faculty Recognition Award in 2012. Professor Ravi Kumar has authored close to 100 peer-reviewed articles that were cited more than 1,000 times with an H index of 20. Professor Ravi also serves on the editorial board of Scientific Reports, Surface Innovations, Advances in Material Science and Engineering, and Frontiers in Materials for Ceramics and Glass. His research interests include the development of novel non-metallic and inorganic materials whose properties can be tuned on an atomistic scale for thermal management, catalysis, and energy applications. Under the Institute of Eminence scheme, Professor Ravikumar is a part of the new Center of Excellence in Materials and Manufacturing for Futuristic Mobility, with a budget overlay of close to 12.5 crores, and is the lead coordinator for the Ceramic Technologies Group. It is my pleasure to introduce the moderator for the webinar today, Dr. Sanjay Mathur. Dr. Mathur is the director of the Institute of Inorganic Chemistry at the University of Cologne, Germany, and is also the Spark Adjunct Faculty at IIT Madras. He was appointed as the board member of the German Ceramic Society and is nominated as the president-elect for the American Ceramic Society 2022. I've just been informed that he is the president of the society now. So congratulations to you, Professor. He serves as the editor for the Journal of Electroceramics, associate editor for Nanoenergy, and as the principal editor of the Journal of Materials Research. He has authored more than 500 peer-reviewed articles with a H index of 63 that were cited more than 14,000 times. He also successfully filed 11 patents and has 13 invited book chapters and has co-edited 2 textbooks to his name. His areas of research include the development of transformative chemical concepts via a deep understanding of chemical processing of functional inorganic materials into applied technologies such as sensors, filters, electrodes, and catalytic supports. Thank you for joining us today, Dr. Mathur. We're very excited that you could be a part of this session. We also have a very distinguished panel with faculty from universities across the world in various departments at IIT Madras today with us. A very warm welcome to all of you. And before we start, a note to the participants, please use the Q&A to enter your questions and upload questions that interest you so that the moderator can prioritize them later. Over to you, Professor Ravi.
Good evening, and thank you very much, Ms. Ritu George, for the kind introduction. And I welcome everybody to this webinar. We just had, on the 3rd of September, we had the inaugural ceremony of this center, and Professor Dr. Alexander Michaelis, who is the managing director of the Fraunhofer Institute at Dresden, made his first presentation. And today's webinar is primarily intended to give a brief overview of the center and give an idea about how this center is going to work and what kind of challenges, technical challenges and scientific challenges that we are going to address in this center. Before I hand over to Professor Sanjay Mathur, I would again like to join Ms. Ritu George in congratulating on behalf of the department and on behalf of the center. And I would like to congratulate him that he has now become the president of the American Ceramic Society. And also he has now been awarded the Woody White Award from the Materials Research Society, I think last week. So congratulations, Professor Mathur, on this excellent news that we heard from you very recently. I now would like to request Professor Sanjay Mathur to get started and possibly let everybody know how this center was conceptualized and also give us an idea of the participating institutions and as well as the collaborating partners from India and around. So he will possibly give us an idea about that. And following that, I would spend some time giving an introduction to the scientific and technological challenges that the faculty members of the center from the Indian side who are addressing some of the scientific issues that I will present it. And of course, if there are questions, the team is also available here to answer any such questions. Over to you, Sanjay.
Hi, Ravi, can you hear me?
Yes.
All right, so yeah, first of all, thanks to you, Ravi, for welcoming remarks and warm word. I also would like to thank Professor Bhaskar Ramamurthy, Director of IIT Madras, for his continuing support. I have had a chance to interact with him during my first visit as a Spark faculty. And at that time, he was already thinking of these kind of emerging technologies and putting them as a cluster to consolidate the knowledge base that you have on the campus. And I also would like to thank the Global Engagement Office, especially Ms. Richard George, because I think I've been to many institutions, but I've never experienced this level of dedication and outreach efforts, and especially to engage with foreign visitors. This is amazing. And yeah, I think this is one of the typical features that makes IIT Madras special and when you are on the campus. So with this, I think, let me quickly share the slides because as Ravi has mentioned that I've been involved with the department, and before I talk about this Center of Excellence for Ceramic Technology for Futuristic Mobility, I should also acknowledge here the vision and international outlook of Professor Ravi Kumar, who has also been the key person and main driving force in establishing this forward-thinking setup focusing on ceramic technologies for a long time. And he's currently the head of the department. So de facto, he's also my boss because I'm a Spark faculty at the end of this year. So, and I'm really glad to have the chance of interacting with the colleagues who are part of this center and those who are in the department. And I think I just would like to, in the American Ceramic Society system, the mandate or the presidency changes with the annual meeting. So my term is 22-23. So I just wanted to make sure that there is, because this is a live presentation. So, but I've been sworn in as the president-elect because this is the transition. The annual meeting was over last week. And now talking about this ceramic technology for futuristic mobility, and I think this has been mentioned. I was very inspired looking at the videos in the beginning because they already talked about some of the first video was talking about sharing the resources. And I think that's also very the German model of like having infrastructure or large unique infrastructure available to the industry. And that's what I've seen in my almost 30 years in Germany, that a society which is really based on innovation and especially engineering is successful due to this industry, academic, and society partnership. So this third mission of transfer of knowledge to the society is very, very evident. And that's why I was very impressed to see that. And then there was another video showing about how self-sufficient the campus is. And it's not only in terms of, I think, the social life, but in terms of scientific and intellectual environment that one sees at the IIT Madras. So I think that's why this scheme is good, Institute of Eminence, but I think IIT Madras is already there, #1 in the ranking that already says everything. That is an international address, and this was again attested in the next video, that most of the students are looking forward to be part of IIT Madras just for this reason, to get the experience that people know when they meet people trained at our IITs abroad. Now, as Ravi has mentioned, we are actually 3 PIs, and Professor Ravi Kumar is the lead PI here. Me and Professor Alexander Michaelis, we are the co-PIs, both from Germany. Alexander Michaelis, he's the director of the Fraunhofer Institute of Ceramic Technology and System. So working very closely with the industry. We are in the middle, working mostly developing new materials, functional technical ceramics, and bringing them up to a scale where we talk about the device integration. Now, the focus on e-mobility was based on a lot of discussion, and it was chosen very judiciously, I will say, by a lot of PIs, because I think this is where we see that one of the major impact of technical ceramics is going to be. So if you see the e-mobility, see the next slide, yeah, is actually one of the most dynamic market of our times. It is continuously reinventing itself in the sense that the understanding is changing every day, the improvement in materials. So it's all materials development and its application, the technology, it's going hand in hand. Whether you look at the batteries, the charging system, the driving technologies, the sensors, all these relevant components, they are requiring inorganic materials, whether they are metals or ceramics, but a major component, a big chunk of these technologies are based on ceramics. Whether it's the area of power electronics or electric motors, cooling, heating, everywhere you will see that functional ceramics are in place. And that's why in this center we have 4 domains. 3 are majorly focusing on experimental development of coatings. So this is one is on nanostructured microstructure coating, looking at new methods of like field assisted processing. Can we control the texture of the film during its deposition, during the production of the film? Then looking at the structural ceramics and composite for mechanical properties. This is where the expertise of Professor Ravi Kumar is. And then functional ceramics and components, how to integrate these new materials into ceramic components. And this is where Professor Michaelis and Fraunhofer IKTS can play a big role. And all this has to be supported by a very deep and thorough holistic understanding. And for this, we are very glad to have a very competent team of colleagues who are good in computational techniques. And once we have worked on these 4 domains, the next step is obviously the performance evaluation, which can be done in collaboration with the industry partners. And I have seen myself that IIT Madras has a very nice and functional, high quality science park with lots of innovative startup companies working there. So I see there are a lot of interfaces where we can expect synergies emerging as we move forward. And from a global technological perspective, if you see, ceramics have always played a major role. And when we come to the point of like revolutionizing or transforming the concept of mobility, that means we are talking about new technologies which have to find a social acceptance. So we need to take these technologies to the people. So that's why we need to make these development people-centric, but it has to have an industry partnership, because then only we can talk about the transformation of society. If we are thinking of change in the mindset, we need to have these partnerships. And that's where the vision and mission of this center is based. Now, I just mentioned that the interdependence of technical ceramics and futuristic mobility, it is, as I mentioned a few minutes ago, there are essentials which are needed, whether it's the heating, the engine, battery charging unit, where you have ceramic components. They are so vital. Without that, you will not have an electrical vehicle. But then there are emerging areas, like the use of piezoelectric ceramics to reduce the amount of cable you are using. You need communication, so putting ceramics, the multi-layered ceramic capacitors. You have antennas so that you can have communication among cars, so for autonomous driving and all. So these high-performance components are mostly based on ceramics. They can be ionic, covalent, or composite, but ceramics, they play a major role. And that's why the focus area of our center are that we want to bring world-class R&D in ceramic materials under one roof. And I think the PIs have realized that there is a need for speed in R&D of ceramics. That's why the creation of this task force, this technical interest group with the global spread. We have lots of PIs, international PIs from Asia, from Europe, from US, and a very big advisory board. And the focus is to strengthen academia industry partnership. And this will be driven by the customization of functional ceramics, so that we can really meet or cater the needs of MSMEs in India. So micro and small, medium-sized enterprises in India, which are actually now building the backbone of the new India. And I think we have seen the success of produce and manufacture in India. And these all initiatives are based on and a very, very fruitful partnership. And that's why the center is going to inculcate, and I will say to produce these, incubate these technologies. And at the same time, we need skilled task force. And that's why the focus is going to be on a research-driven training in an international and intellectually challenging environment. And this is something that will be an add-on in this center, which will also enhance the international visibility of IIT Madras. Now, coming to the research thrust, we are in the first year of the centers. They will be evolving, but at the time of when the proposal was put together, we were very clear on this, that we will be focusing on innovative ceramic technologies, and with the intention of having a faster transfer of knowledge, new knowledge and material synthesis into ceramic coatings and components like telecommunication, microwave industries, 5G antennas, and so on. And this effort should strengthen the position of IIT Madras on the value chain of ceramic engineering. For example, battery materials, hydrogen electrolyzers, recycling of ceramics. Battery recycling has not been a big topic in India, but it is going to be once we start having electrical vehicles all around. And then cost competitive processing and customization of technology, because I think any new technology is now having, or they are imposed with constraints like of recycling, life cycle analysis. And that's why to lower the initial barriers for technology transfer, we need to also have a complete plan going from cradle to cradle. And this is where we have partnered with Fraunhofer that who are already well placed to execute these kind of activities. Now, in terms of the current trends and needs that are obvious and are related to futuristic mobilities, ceramics for energy application. So we'll be working on fuel cells. This is the expertise of IKTS, batteries, solid oxide fuel cells, photovoltaics, ceramics for environmental applications, sensor, catalyst, engineered ceramic for ICT and medical applications, advanced ceramic pigments and coatings. They can start from the car paints to materials or inks or slurries for additive manufacturing. And I just wanted to give you two examples, two flavors. One is that when we are trying, and this was mentioned by Professor Ravi Kumar also, that we would like to close the gap between the lab scale research and industrial application. So this is something that is not done in one step. It has to go through the complete from development of the material, meeting the figure of merit criteria that industry has given, and then integrating it into the device and to evaluate the functional performance. And some of the things that we are looking at and have got experience in the past is whether these are electrolyzers for hydrogen production, because this is going to be an important technology for fuel. Then obviously catalytic converters, where we can take ceramic pre-folds and they can be immobilized with catalyst or single atom catalyst using thin film technologies, and batteries. And going away from lithium, we are now working on sodium and magnesium batteries. So this is also an emerging area, which is, so I think in terms of the roadmap, it's very clear. We would like to scale up the synthesis of ceramic materials, which have been developed in large number of groups, and different PIs have access to that. And how to take these new processing routes for advanced ceramic and do the functional integration of these materials into device concepts. And once we have done that, the next step would be technological application and technology transfer. So this whole, I will say, enterprise is to develop and offer a collaborative research and training environment. And this is obviously going to expand the existing international network of partners at IIT Madras, which is already huge. But through coordinated action by using multilateral collaborative instruments, because certain facilities like synchrotron and all, where we can do in situ experiments, we need to go out of Chennai and do the experiments, but we have partners for correlative microscopy, all attached to, for example, BESI in Berlin or in Sweden. So in synchrotron, I think these materials challenges, they will be addressed through the expertise of this consortium. Obviously, we are looking at a world-class research and training environment for not only the PIs, center members, but also for young professionals, master students, PhD students who can go out, do a part of their thesis, master thesis or doctoral thesis with the partners. Also, there is a plan to look into a new educational program, because there are international master program supported by the European Union, joint doctoral degree. There is a scheme between DST and DFG to have jointly supervised PhD. Establishment of graduate school is something that can be done, where you can have faculty teaching at both places, or one in India and other in some partner institution. And then finally, to achieve a vertical integration of science and engineering. And I think that's why IIT Madras is an optimal place to realize the goals and also to meet the needs of the local industries. The second example I would like to hear briefly, because Professor Ravi Kumar is aware of that. It's also it came out of a PhD, and this is on the new material perovskite solar cell, which is a photovoltaic material, which was developed like in many labs, very like a lot of people are working. It's a, I will say, a vertical starter. It has in 10 years achieved photovoltaic conversion efficiency higher than silicon. And because of its ease of processing and abundance, this has become material of choice for flexible photovoltaic for all kind of application, for large scale application. And we have been working for a few years, and one of my PhD students, so this is my own example, that's why I'm giving, he started making these inks. The idea was because this material is highly hygroscopic. And Dr. Shanol, who has worked on this, he came up with a new method of using a material that will make these inks water stable. So for this, he has used special kind of ionic liquids and has tried that they can be printed and to make printable photovoltaic. With this idea, he moved to a company the company Solar Technologies in Poland. And after 2 years, he has founded his own company, Solawini. He has an address in Cologne, where he is developing large-scale carport panels for energy harvesting, and at the same time also shutters for the building. So this is a very good example. Within 5 years, the technology has been developed by a PhD student, has been transferred to the market, and has been taken into new products. So here you already see they had a perovskite there, and then these shutters which were actually having these perovskite solar absorber film. So this is very encouraging for especially my generation, where we were mostly working in our PhD thesis in publishing high quality papers, which is also needed. But at the same time, I think this new shift or paradigm change that people are now looking into the impact of the science that they are doing is a very welcoming facet in the academia. And I think with this, I would like to also say that and acknowledge all the Indian principal investigators. I saw that many of them are online, so I really would like to thank. And I think with Professor Hari Kumar, we are already working, but I'm sure that we'll have the chance to work with others as well. Professor Sudeep Chakravarti, with him, we have worked on when he was at IIT Indore on perovskite materials, but I'm sure that there are other interfaces. I've heard about Professor Arunachalam's work on microwave, and I think there we see also very good overlap activities. So this is actually, I will say, substantiated by our international PIs or associate members who are from all over the world and coming with unique expertise, both infrastructural and scientific. So I think altogether, this is going to be a very, very fruitful journey, and I'm very happy that we are starting. We had a slow start due to the pandemic situation, but we are looking forward to also have an international conference as a kickoff meeting early next year, so that we can also, at the international scale, announce that the center is in place, it is operating, and I'm sure that at least some of them are aware that RWTH Aachen has a partnership with IIT Madras, and Jochen Schneider has been many times there. I also have other people who are faculty or who were for 5 years in it. And I also would like to acknowledge our advisory board member who are big names in the ceramics. So we see Dana Goski, immediate past president, and Professor Elizabeth Dickey, who is currently president till next year, till an annual meeting. And we have a lot of other colleagues who are well-known figures in the ceramic science and technology. And that's why I think if you see, this is a very nice scheme that Professor Ravi Kumar has made, that we have made it in a concentric way. So the center is very well embedded in layers of expertise, layers of strength and infrastructural facility. So I think it's in a very safe and fruitful environment. I'm sure it's going to grow as it was planned. And I'm sure that this is going to lead to new collaboration, both at national and international scale. Obviously, we have several deliverables, but as I said that I'm not going to go into all the details. I just gave you one example of the solar absorption coating and some of the other materials in the beginning on the coatings. But in terms of the categories, we really would like to have a scientific impact by having publications with multiple PI to really show that this is a collaboration where people are exchanging ideas, expertise, new problems are being identified, to have a technological impact. And here we hope to commercialize at least some of the technologies that will be developed in the center, to incubate them and to bring or offer the support to a level where students can think of having their own startup. And this outreach, and I think this was what I remember Professor Bhaskar Ramamurthy was saying, that we need to, through this initiative, increase the footfall of eminent scientists and technologists at IIT Madras. But I've seen Spark faculties, Vajra member, one of my close friends, Ajayan is in the chemistry department. So I think there are already, I don't think that IIT Madras need that support, but I think it's a great place to start. And I'm very happy that the center has been established. And I think at this point, I would like to hand over to Professor Ravi Kumar so that he can talk about some of the concrete ideas. I just wanted to give you a global perspective why Fraunhofer, which is the largest Fraunhofer in Europe with 750 members, decided to enter into this partnership. And why University of Cologne is so keen on this, and there will be an institutional support. And I think we have done everything to have a good starting bed, and I'm looking forward to the support of the PIs and also in the discussion that we are going to have. But with this, first of all, I would like to hand over to Ravi, and if there are any immediate questions, I would be happy to take them now. But over to you, Ravi. Thanks.
Okay, thank you. Thank you, Sanjay. If you can, So I think you can see my slides. And thank you, Sanjay, for giving an overview of the center and also talking about some success stories from your lab. I think Sanjay has already mentioned about the different domains that the center would focus on. The first three ones are the experimental domains, and these three experimental domains are connected by the horizontal domain, which is the domain of computational material scientists. We have 4 computational material scientists who are involved in this center. I'll just talk about each of the PI's contribution to the center in the next 5-10 minutes. As Professor Sanjay already mentioned, in this center, we would not only be addressing some very fundamental scientific problems, but also we would look at some technological challenges associated with certain problems. And we are looking at lab to fab approach. And in order to achieve this, we have a highly interdisciplinary team comprising of experimentalists and computational material scientists. I think Sanjay has already mentioned that to you all. Let me start with myself. I am mostly who worked extensively on structural ceramics for quite some time. I'm looking at some of the challenging problems related to producing ceramic fibers, for instance. We are looking at certain ceramic coatings which might be useful for the aerospace industry, ceramic coatings on, say, metal, ceramic composites, and so on. We are also looking at certain interesting problems at the energy sector by designing some precursor-based ceramic materials with in situ crystallized soft magnetic phases for developing ceramic materials with a high figure of merit. And we are also in the lab, we are very much interested in developing certain class of materials which can be useful for the aerospace industry. Professor Manas, who is also from the Department of Metallurgical and Materials Engineering, is an expert in the area of ceramic foams in general. And in this, within the context of this center, he'll be focusing quite a bit on developing ceramic foams for not only structural applications, but also for functional applications. He has developed his own patented emulsion technique for producing ceramic foams. And he intends to use the technique that he has developed for eventually 3D printing some of the ceramic foams and so on. He's also part of the additive manufacturing group under this larger Center for Materials and Manufacturing for Futuristic Mobility. So, so he, within this context of center, will be working on ceramic foams. Professor Swaminathan, Parashuraman Swaminathan is a faculty member of my department again. His focus is on functional ceramics and composites. He intends to work on developing transparent touch displays for smart window applications, develop certain metal oxides for sensing applications and so on. So you can see that he has already been working on these topics for quite some time, but some of these topics are very relevant to mobility issues, and then he's we hope that he would be contributing to the mobility concepts as well. I would then like to introduce Professor Lakshman Neelakantan from the Electrochemistry and Corrosion Laboratory of, again, my department. He intends to work on developing metal oxide nanowires for functional applications. He collaborates strongly with Parashuraman. And he's also interested in working on smart coatings with novel metal oxide inhibitors for corrosion inhibition for automotive applications. And I think most of these investigators are here on the panel, and if there are any questions, they should be able to take them. Professor Kavita is a professor in engineering design. She works on ceramics for microwave applications. Some of the topics that she intends to work on within the context of the center is on designing antennas, microwave antennas, and low loss ceramic substrates for microwave applications, and again, for low profile microwave absorber design. So we are collaborating with her in developing some ceramic materials in our lab, and which can be upscaled and eventually used for device fabrication. Professor Arogyarajan is a professor in applied mechanics at IIT Madras. He has expertise in developing piezoceramic based sensors. For instance, he develops piezoceramic based magnetoelectric sensors for pressure sensing. He develops lead-free piezo ceramics for green technology. So by and large, his research focus is on developing piezoceramic based materials for a variety of applications, which includes sensing, sensors, energy harvesting, and so on. Professor Dilip is a faculty member of Department of Physics at IIT Madras. He heads the soft matter laboratory, and for quite some years after he has joined IIT Madras, he has been developing flexible thermoelectric materials. He produces very unique compositions of ceramic and polymer composites, which can be used for developing thermoelectric based flexible energy generators. And of course, with Dilip as well, we have been collaborating for quite some time. I mean, I have just tried to give some of the research problems that they are planning to work on. Of course, they have many more scientific challenges that they would like to take up, but in the interest of time, I will not be able to discuss all of them. But this experimental research is strongly driven by computational material scientists. We have 4 material scientists working on this problem, 2 from IIT Madras, 1 from IIT Bombay, and another one from Harishchandra Research Institute in Allahabad. So as you see that the faculty members work from electronic structure calculations to machine learning, developing machine learning algorithms. Let me start with Professor Hari Kumar from the CalFIRE lab of IIT Madras, with whom I collaborate extensively. We have been working on various carbides and carbonitrides for ultra high temperature applications. And in the context of, again, futuristic mobility, again, we are developing some of these materials in our lab, and we extensively work with Hari Kumar on understanding the phase stability and phase equilibria. Of course, he uses a lot of computational tools and helps us understand some of these concepts and helps us refine our experiments. And we are also interested in recent times working on some high entropy ceramic materials. And he's helping us with thermodynamic modeling of phase stability of some of these high entropy ceramic materials. Anand again is from IIT Madras, from Computational Mechanics Lab. Anand and Alankar from IIT Bombay are interested in using machine learning tools for solving some of the scientific and technical problems. Professor Anand uses machine learning tools to predict local micromechanical fields in multiphase materials. As you can see that traditional techniques, which is based on physics-based models, are usually quite cumbersome and quite computationally expensive. So he has been in recent times interested to leverage machine learning techniques to predict the local fields. Alankar, focus of Professor Alankar from IIT Bombay is on artificial intelligence aided multi-scale computational mechanics for materials design. Of course, he has more than 3-4 problems that he intends to work on within the context of the center. I have just displayed a couple of them here. In fact, that is of very much interest to a lot of experimentalists. One problem is on understanding the deformation behavior in multi-layered materials. And he's also very much interested in machine learning based models to understand deformation in heterogeneous solids. And of course, another topic which is of very much interest to most of us is on machine learning for discovery of materials and properties. And again, he has been in recent times also working on dynamic crack in functionally graded anisotropic brittle materials. Last but not the least, Sudeep Chakravarti is from the Harishchandra Research Institute, and one of the challenging problems that he's looking at is on materials modeling for energy scavenging, and that is basically to develop transition pathway prediction methods. And he tries to probe catalytic pathways and understand structural transformation and diffusion mechanisms in battery materials, and also work on hidden mechanisms in some of the ununderstood mechanisms in hybrid perovskites. These are the topics that he would like to work on as a computational material scientist and in collaboration with experimentalists within the context of the center again, and within the context of the broad theme of futuristic mobility. For people who are interested to connect and collaborate with us, please look at our website, which is www.ctfm.in. We keep the website updated. All the information is available. All the center partners, information of all the center partners are available, and all the news and events are also kept updated. If you have any questions, certainly write to the center web email, nvrk@ctfm.in, or you can write to me at IIT Madras, or you can also write to Mathur, Sanjay Mathur at University of Cologne. Of course, we welcome collaborations. We welcome students to work with us. Of course, you are free to interact with all the investigators. Please do feel free to write to them directly for PhD positions, and as well as if you are from the industry, you are free to collaborate with us. And at least the Indian partners are all on the panel, and if there are any questions, they should be able to take. And they should also be available to be contacted if there are any collaboration opportunities from the industries and so on. With this, I think I thank everybody for listening. And I think we both, myself and Sanjay Mathur, we were able to provide you an idea of how the center is designed and what are the objectives, vision, and mission of the center. And at least in the phase one, which is going to end by the end of next year, we have set some targets, and I have tried to present some of those challenging problems of myself and my colleagues that we intend to solve within this center. So thank you very much. If there are any questions, we should be able to take them here. Thank you. So are there any questions for me or for Sanjay Mathur or for any of the investigators who are part of the center? All of them are on the panel, so they should be able to answer any of those questions.
So there are two questions that have come in from the audience. It's in the Q&A box.
Yeah, I see them. One is, but I think somebody who is in the metal or metallurgy is from Aditya Mishra. Can you shed some light on the future possible application of direct bonded substrate manufactured using a metal and a ceramic?
Can you shed some light on the future possible applications of direct bonded substrates manufactured using a metal and ceramic? I'm not sure if I understood the question correctly. At least what we have been working on is providing ceramic coatings on some of the metallic substrates. We are currently working with the Vikram Sarabhai Space Center, where we are interested in providing some thermal barrier or environmental barrier kind of coatings through precursor route. And that's what we have been doing. I'm not sure if I understood this question correctly, but that's what we have been working on. And that is where my experience and expertise lies with. The other question is, titanium reduce the thermal conductivity of, does titanium reduce the thermal conductivity of direct bonded copper substrate prepared with alumina when titanium is doped with metal melt for improving the wettability of melt while joining? I'm not sure if these questions are, I possibly, I don't know if it has to do directly with the welding related issues. So we are not really looking at these kind of problems. at least I'm not competent to answer this kind of question. We are, for example, in my lab, we are looking at, say, developing certain precursors which can be coated on to metals or ceramics, and eventually which can be converted into a ceramic coating. So that's what we are looking at least in my lab. Sanjay, you have any specific examples to answer for that question? At least I don't know.
Yeah. I mean, that's also not directly my expertise, but from the viewpoint of chemistry, one can say that if you are adding titanium and you are doing welding in ambient, then obviously the possibility of titanium oxide being formed and that being a ceramic will reduce the conductivity. So I can understand. And that will obviously also reduce the wettability probably at the interface. But yeah, without having any experience in those experiments, I can just say that, yeah, that's likely that this may happen. But I can't comment more on that.
Yeah, thank you, Sanjay. It is not within my domain of expertise, so I am unable to answer that without having done experiments on that.
But I can take the next one. The next one is Alekhya Kumari Khyama. She's asking, I have completed my graduation. How can I join this after my master's? So I think this Professor Ravi Kumar, but I'm just saying that if you are willing, there is a possibility that your master thesis could be jointly supervised by an international PI and a PI from the cluster or from the Center of Excellence. And even if you would like to have would like to do a part of your thesis in a foreign lab, that should also be possible. But I am sure, Ravi, you can comment more on that.
Yeah, see, when I think you can join only the department. So depending, I don't know what is your background. If you are from a metallurgical background or a mechanical engineering background, you can certainly join for masters in metallurgy. Of course, you can also join other departments here. If you can do a master, MTech, or a master's by research. You certainly require GATE score if you have to be funded to do your masters. And of course, internship, it is possible to contact any professor, and if it is possible for the professor to hire you, yes, you can contact any professor with whom you would like to work with for the internship.
But I think center can facilitate that process.
Yes, certainly center can facilitate. Yes.
Yeah.
Yeah. Are there any more questions?
I see Riaz Ahmed has his hands up, but so he's among the, yeah, I just see.
What's the best way for a micro SME to engage with the center? The best way is if we know what is that SME is working on, then you can find out who is the faculty member or who is the professor who has experience and expertise on that topic, and certainly you can approach them directly. You have seen that there are around 12 Indian faculty members who are associated with the centers, and around 12 international participants as well. You can directly connect with the concerned faculty member and engage with them directly.
And on top of that, I think we should mention that in most of the European countries, they have a partnership program with India. That means, like Ravi, from the 2+2,
yes,
there is also a possibility to choose a foreign PI and then have an Indian PI. And this 2+2 model works like this, that you have one industry partner on each side. For example, if you would like some German company to transfer their technology to your company, your SME, then you can partner with one of the IIT Madras faculty members and one from Germany. This could be Professor Michaelis or myself. And then we can apply to the Indo-German Center of Science and Technology, and they give you a very good funding for a 3 years project where you have a real project focusing on the transfer of this technology and bringing it close to the market. So there are financial means also to support these kind of activities.
Yeah, Nishal, I don't know what is the micro SME that you are talking of and what is the focus of that micro SME, but you know what is the, if you go to our center website, you will see the details of all the scientists and professors who are involved in the center. You can directly contact them and engage with them. And as far as research internship is concerned, again, please approach any one of us and based on the vacancy and depending on if there's a funding opportunity, yes, certainly we can fund. So you can approach whomever you want who are part of the center. But of course, each of us are associated with the parent department, so you will be within a department, okay? But that is possible. Any other questions?
I still see the hand up, Riaz Ahmed, and then Ashish Singh, but Ashish Singh has gone.
Any of the other panel members who are part of the center would like to say anything?
Professor Ravi Kumar, this is Kavita here.
Yeah, please, Professor Kavita. Yeah.
Yes, thanks for presenting a brief overview of our center in this webinar, and thanks to Professor Sanjay Mathur as well. I just want to add to the question asked by one of the participants regarding the direct bond substrates. One application, as you mentioned, is for high temperature coatings, but when it comes to electronics, PCB substrates, it's a very good replacement for conventional PCB substrates, which have very poor thermal conductivity. So for a lot of high temperature applications, power electronics, ceramic metal coated substrates could be a good replacement for the better thermal management. And that is one another application that one can look at. And that's what we are also hoping. We are not looking at high temperature applications for microwave antennas and wireless futuristic mobility, but it also has applications for a lot of high temperature power electronics circuits, and wherever it's needed in space application, MIL standards, where they have really high operating temperature, the conventional PCB fails, and this could be a good replacement. Just wanted to add to that answer you gave. That's all. Thank you.
Thank you.
That's great. Yeah.
Thank you, Professor Kavita, for the clarification. Thank you so much. Anybody else in the panel? Any of the center members would like to say anything or comment further? Okay, if there are no more questions, I think I would like to thank everybody. Thank Professor Sanjay Mathur for sparing his valuable time. And I would like to thank all the Indian PIs who made it to this webinar. And I would like to thank the Office of Global Engagement for arranging this in a very professional way. And certainly all the audience who made to this webinar. As I have provided you in the one of the last slides, please feel free to contact any one of us, either for working with us or collaborating with us. Thank you so much, and over to the Office of Global Engagement.
Yeah. Thanks also from my side to the office, and obviously to Ravi for hosting this seminar. And I really enjoyed, and it's good to see that there is so much of interest from the attendees. So I think as the center develops, probably we need to also collect all these thoughts, like the students who are interested in upcoming or emerging ceramic technology. So probably there are some action items, but it was a very good session. So thank you very much.
Thank you. Thanks a lot, Professor Sanjay. Thanks a lot, Professor Ravi. We really thank you for taking time off your schedule and doing the webinar with us and talking to us about the research initiative and about what you've been doing. So thanks a lot. All the very best from all of us here. And thank you to all of the participants and everyone on the panel. Thank you. Have a good day.
Yeah, thank you.